Take it
Thank
away.
you. Thank you. Thank you. My name is Tinashe. Thank you so much for having me again. I just want to reiterate what John said. Project Club is just a very fun place to, if you've got data science related stuff that you're doing at work, or if you're a student and you just learned something new, or if you just have a presentation that you just are super passionate about, which is what I'm doing today. This is a great place to do it. So head over to Slack and find the Project Club channel, get involved. It's a very welcoming place. And with that, I will get started. Today, I'm going to be talking about something called notebook-driven development. And this comes from a very personal place. Because I personally, although I've been working in data science and in academia for many, many years, I'm not a software engineer. I've taken courses in C++ and Haskell, mathematical foundations of programming. Like I've been in those courses, but my undergraduate was actually in psychology. And so all of the computational stuff that I had to learn, like NP completeness, runtime complexity, and like all those things, they're not really like what I was excited by when the idea of programming came around. And that's just because I think there was no real serious pedagogical way to get somebody of my background excited about it, right? There are some people who like just naturally like latch on to like all of these like programming principles, but for myself it took something else. Like I was literally struggling my way through programming. And so part of it is because it's not just that programming syntax is hard, but just understanding some of the concepts, being able to think through the concepts has always been very, very difficult for me. And I think this is part of how the infrastructure of programming has changed. Because in 1980, back when people were actually using physical punch cards, when you were programming, what you were literally doing was taking a sheet of paper and punching in physical space, ones and zeros kind of thing, right? But today, you can open up a tutorial and go onto Google Colab or whatever, Hugging Face or anything, and you can train a neural network out of nowhere, right? And that neural network can do things that 10 years ago nobody thought was possible. But because of how the technology around us has been developing, and because of the fact that so many of us in technology are so open to sharing what we learn, it's super easy to follow somebody else's tutorial, even if they're not like a huge professional in the field. You can still like open a random person's blog and learn how a new library works. And I think that this lowering the barrier to implementation is a very, very good thing. There's the idea of the high tower, right? The academic bastion, where you can't really call yourself a mathematician unless you have a mathematics degree. That's not really the case in technology and programming. I think that the culture of programming is really, really welcoming because a lot of people just say, hey, if you can just like open up a computer and code some stuff and build something that you're interested in and it works, that's good. That's always a good thing. And I think that's a very, very nice part about the culture of programming. And as we've been building on this idea of like a broadening of programming languages and programming styles and software development, and as it's become more monetized, right, companies need to start to use this. There have been the development of software paradigms. So you can see if you Google some of these, you can learn a lot more about them, but I'm just going to list them off here. Test-driven development, behavior-driven development, domain-driven design, model-driven development, configuration-driven development, component, scientific workflow, contract property-based design, literal programming. These are all things that have come up out of the fact that programming is not a closed gate arena, people can come up with their own ideas and test them out. And as companies have invested in technology, in those companies, a lot of people have come up with their own development cycles and development styles. Some work better for different jobs, but some work better for scientists. And that's important because here in this community, we are called the data science learning community. Data science is something that, as you all know, came up about 10, 15 years ago, where we were just saying, okay, companies are just producing data and we want to make sense of it using statistics, machine learning, and all of these other very fancy tools, right? So what works well for scientists who are trying to derive insight from data using programming? Back in the day, R was a language that came up specifically in the statistics community. It descends from a language called S, built for statistics, not necessarily software. It's got some weird functional object-oriented features, and I really don't want to get into an argument in this conversation about why that is or why that's good or why that's bad, but just know that R is a little bit archaic. It's kind of weird. It's got some kind of like weird features that like work well for scientists who are doing statistics all the time. And what ended up happening as R came to its maturity, it provided an environment that was reducing the overhead of actually doing the programming. But that meant that software engineers looked at the environment and the workflow and the people who were programming in R and were kind of like, this isn't real software engineering. Even though R is a programming language, software engineering just didn't really have a lot of respect for the R ecospace. Why is that happen? Why did that happen? Because educators were saying to themselves, you know, how do we like simplify the expression of programming without trying to put too much burden on the people who were actually doing the work? One of the things that came out of that, and it's not unique to R necessarily, but is very popular in R, was the REPL, read, eval, print, loop in the command line. And what that means is that instead of writing a full script of instructions to your computer and saying, do 5 tasks at once, you say, hey, open an entire shell, an entire process. And whenever I have a new task that I want to do, I'll just send it to the computer, and then you read what I tell you, evaluate what it is, and print it, and then come back to attention. That's what REPL means, read, eval, print, loop, right? And what this effectively enabled is the world of literate programming, which is a term coined by Donald Knuth. I think the original paper is from 1984. If you are not familiar with this paper and you write code in R or Python, you really, really, really should read this paper because it's foundational to a lot of what you see in the ecosystem of R and Python data science right now. Really, really recommend reading this paper. But the whole idea is that instead of having a script, you have a file that can be read by both the computer and the human who's writing it. So instead of just having code, you have some code and you have some writing. Instead of just having writing, you have some writing and some code. And these two pieces sort of move together. And the first way that that was developed, as far as I'm aware, in R was called Sweave. That led to R Markdown, which led to Jupyter, which led to Quarto. Many of us in this community are familiar with those tools, especially the LOS3. What it enables is you have things like inline plots, you have the embedded narrative of why the plot was being developed, how it was developed, why it matters. It basically puts the code and what the code does in one place. And this was something that, at least in my opinion, really launched R into a respected position in the data science community because it was perfect for teaching, for prototyping, exploratory analysis. I don't explicitly know the timeline, but I'm fairly convinced that Jupyter and R sort of happened around the same time. And that's part of why Jupyter and R, why Python and R are both seen as the data science languages. I'd love for somebody to correct me if I have that timeline wrong. But the thing is, traditional software engineers that we were talking about don't like notebooks. Why? Well, if you Google notebooks and software engineering, or if you've ever gone down one of those terrible Reddit rabbit holes, you'll see things like, wait, what do I have to install to run this? How come it says you ran this cell before you define that? How do you track this with Git? Can I just import the notebook as a module? How do I test it? Blah, 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 blah. To summarize a lot of those arguments, I've gotten at least 7 that I think capture the large argument that, a lot of people present. And to be honest, if you really want to understand this very well, I would say just YouTube it. There's a very, very long but comprehensive talk by someone whose name I'm not going to mention because I don't want to discredit them. They are a very, very talented software engineer, but they have a very famous talk on why they don't like notebooks. I don't know if they still share that opinion, but I would just say that from that talk is where I got most of these arguments. Nonlinear execution breaks reproducibility, which is the idea that in Jupyter notebooks, or sometimes even in our Markdown notebooks or whatever, people can run certain code commands and send it to the REPL, and then it comes back, and you might run something, and then you might say, oh, wait, I want to fix that thing, and then you go back and run something above it. And that means that the linear flow of how a computer reads code is broken. Makes sense. The hidden state leads to misleading results. This one is sort of important, related to number 1, but is more sort of to do with the fact that a notebook is an interface that hides a lot of different things that are happening behind it. And that means that if you don't fully understand how the notebook works, there may be some unexpected things that could happen. The third one, it's difficult to refactor into reusable components. This is just the idea that once you've written the code and it works, you may not be motivated to take that code and write it in a more accurate, more compliant, more efficient way. Which happens, right? Once you've written something, let's say you've been working for an hour and it's like, oh my gosh, like it finally worked. If I asked you to go back and like write it again, no, you don't want to write it again, obviously. Number 4, version control is a mess. If you've ever tried to look at an IPyNB file in Git, you may notice this because an IPyNB file is full of all sorts of JSON elements that are just sort of moving around, and they don't really make a lot of sense to the human reader. It's very, very hard to version control the traditional notebook. And the 5th one, there's a lack of separation of concerns. This is one that is particularly important for software engineers who say, okay, if you're writing in a test-driven development paradigm, what they'll say is, okay, I'm going to write the test first for a function before I write the actual function. It's a very, very efficient way to write large pieces of code, but a notebook won't allow you to do that because the notebook kind of has everything all in one interface, right? And then the 6th one, they say it's difficult to test automatically or integrate into CI pipelines. Related to number 5, because the notebook kind of houses all of the things around the software that you're trying to produce, it may be difficult to integrate into, say, Circle CI or other tools like GitHub Actions, where GitHub Actions is expecting to run a specific file one at a time, but a notebook might not lend itself well to that process. And the 7th one, this is the one that really irks me the most. I'm just going to forget about it anyway, right? A lot of people think about notebooks as this sort of like sandbox, this kind of playground where you just kind of want to see what something does. But then once you're done with the notebook, you don't really care what happens to it. It just kind of evaporates into your memory. Some people don't even bother keeping it in their actual Git track repository. So let's review. When notebooks shine, we're talking about things like exploration. We're thinking about teaching, collaboration, rapid iteration. But software, especially professional software, they want to use scripts. They want to test with continuous integration or continuous deployment. They want to manage their dependencies. In data science, we do that with like Renv or Conda or whatever. Both have a place. But my argument is that because notebooks are a form of thinking, I think there is something very, very important about it. I think there's a middle ground. There were two tools that I've been investigating for the past 2 years-ish. One is called Fusion and one is called NBDev. The idea is that you start messy, like you usually do with a notebook. You explore, you experiment, you write down what you're thinking and how you're solving your problem. And then gradually, you take that same notebook and start to imply some structure on it using code. And then the tool, either Fusion or NBDev, then looks at what you've done in the notebook, takes all of the structure that you have annotated, and then generates the code that would be more permissible or more traditional in software engineering. The tool can then go on to then publish something more human readable in the form of docs. And if you're in the R community, you may be familiar with like package down. In the Python community, it might be like Sphinx or something like that, where the documentation is actually produced just from the actual code itself. So these are two tools that I've been using for about 2 years, and they are very, very, very powerful. The idea is that your notebook becomes the bridge between the creative problem solving that you were doing in data science and the sustainable software that is expected of you as a programmer. What I love about this notebook-driven development is that it embraces all of this exploratory, iterative stuff. It encourages you to narrate your code as well, which means you're not just thinking about why you wrote the code, you're also explaining what happens at every stage that you're actually producing it. And what I love about this is that it makes programming accessible as opposed to diluting the space of people who can solve problems, which means that to me, it's software that holds my hand. Because one of the largest challenges that I had that R Markdown solved for me when I was learning to program was, let's say I'm investigating a print formatting library, right? Whether it's in R and in Python, like sprintf or whatever it is. In order to understand how to, like, let's say a simple problem like print a triangle in the command line, a triangle of star symbols, I might have to first open the entire docs of that language. And then from there, I might have to open up the sprintf documentation of that language. So now I'm in the function documentation. And now I have to learn, or at least read through a couple times, each of the arguments in sprintf over and over and over again, so that I say, okay, well, if I want to run a script that prints a triangle, I need to at least understand, like, okay, here's where I put some spaces on the left-hand side. Okay, but wait, if I need space on the left-hand side, I need space on the right-hand side. What's the argument to put spaces on the right-hand side? Okay, now that I've put spaces on each side, how do I know how to increment it so that I can put fewer spaces on each. You know what I mean? This iterative problem solving is something that I found very, very, very difficult with traditional script-based software, because I would have to write the whole script, including in Python, if name equals main, blah, 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 go to the actual command line, run the Python script, hope it works, and then from there, solve the problem with the sprintf library, right? What notebooks do for me, what they did for me when I was learning to program, was that I could just import the sprintf library at the top of the notebook, print out what sprintf does in the next cell or in the next line, print out what happened if I changed one argument, print what happened if I changed the next argument, print what happened if, etc., etc., etc. And that was a very hand-holdy way of my learning to program. And I just loved that. I don't think that I would be a programmer without that experience. So, to summarize, the printing and feedback in a notebook is immediate. You don't need to save the whole script. You don't have to rerun it. You just send code to the REPL and you see the result immediately, which means you get shorter feedback loops, which prevents analysis paralysis, which I am very, very guilty of. If I have too much to read in one go and too much to understand, sometimes I can't even get started. And I don't have to memorize the entire API to get started on the thing that I'm trying to do. The next thing is interactive introspection. If I have a list or a data frame of data that I've been constantly iterating over, I don't have to split multiple scripts to iterate over the manipulation of that data, right? Because what's the one thing that is really bad in software engineering? If your script is too long, they say, okay, it's too long for you to keep in your head, split it into two scripts. What happens if you split it into two scripts? It means that now you have to start saving objects out of your environment and bring them back into the next script over and over and over again. I hate doing that. It's so irritating. So a notebook allows you to iterate over those bits and pieces with immediate feedback, which lowers the barrier to entry because you're not fiddling with as many pieces, but you're also encouraging the experimentation. If the experimental environment is open, it's going to be a lot easier for you to iterate. So the other thing is that the code and the narrative are both in the same environment, which means that the documentation is self-replicable. It's just going to be there, and it makes the thinking visible, which I think maybe is not super important for, like, I don't know, like a bank building some kind of like tool to like read transactions or something. But for science, having your thinking visible is so important, because everybody, including yourself, needs to be able to read this in 6 months, in a year, in 5 years, and say, oh, I understand what that interpretation was. So, to be fair, it's not a pattern that fits everything, right? Like I just mentioned, if you're in a bank writing some tool that like processes transactions, maybe this whole like data wrangling, fitting models, making plots, and like maybe all of this stuff isn't useful. So notebooks aren't the ideal way to develop your software. Maybe you're going to take the more traditional software engineering route. The other thing is that once you're moving to more towards like traditional, or rather large scale software products, you may need to actually enforce more structure than a notebook. But I do think that this is a middle ground, because notebooks will still offer a path to your insight without having to go around these rigid structures. And I came up in academia, so I want you to think about, you know, a PhD student with one PI, right? And they're solving, you know, maybe they're like solving some fundamental problem about the nature of the universe or something like that. They might be writing a Python script and then just sending it off to their PI, and the PI is like, okay, I ran it and like it didn't work. And then they go back to the PI, they go back to the student, and it's like, oh yeah, whatever, like it runs on my computer, right? But because you didn't put any thinking into it, it's hard to explain without the actual writing about what was happening. On the other hand, you could have like a 300K per year paid senior engineer writing like all of this amazing code for like the FDA or whatever, right? Where it's super important. I think that those two extremes, notebooks provide something in the middle, especially when we use the tools like Fusion and NBDev. And also thank you, John, for posting the actual links in there. Check the chat. If you are interested, just click on it. Make sure you have that open in another tab. So for Fusion, this is primarily for R. You start with an RMD or QMD. And if you're familiar with RMDs, each of the blocks of code in RMD have these like meta instructions in them. And what Fusion does is it says, hey, how about you add a couple more meta instructions, and our tool Fusion will specifically read for those, and it will extract each of the chunks into the relevant place for an R package. And what that works really well with is something like package down, where you can then package both the R code and the documentation and publish it on your GitHub Pages site. The alternative in Python is called NBDev. You can start with I, Q, and B. QMD is not officially supported, but there is a pull request that I have been using in NBDev that works perfectly well. It's just taking a little bit of time for them to officiate that pull request. But the idea is that you just use special comments in your IPyNB code chunks. And then NBDev will then look through each of those code chunks, export the relevant tags in the code chunks to generate the same thing as we just mentioned with package down. It'll extract to the modules, and it'll generate the docs in Quarto. So to, super quickly summarize, you write your narrative, exploration, you prototype your code in one file. Special tags go out to r/scripts, r/test that, package documentation, including the examples, and all of the vignettes, which is really awesome. NBDev, you take a Jupyter notebook, you comment on everything that you think is important. The .py files are generated automatically from the IPyNB. If you've used NBConvert, you may be familiar with this. NBDev builds on that technology to sort of make it a little bit more flexible and accurate. What's interesting about NBDev is that it considers the notebook itself the test. So they provide a couple of different functions that just say, okay, in your notebook, if your code cell doesn't run without an error, then it's actually failed the test in and of itself. And of course, it's backed by Quarto because they are working very closely with JJ Allaire to make sure that like their documentation is just as easy and straightforward as possible. And with both of these tools, it's also bidirectional. If you update the notebook, it updates the modules. If you update the module, you can sync back to the notebook, which is really awesome. So let's review back to these common arguments. Again, just YouTube this. I'm not trying to call out the initial developer who is behind this YouTube video, because I do respect them. I don't want to talk bad about them. But nonlinear execution breaks reproducibility. Well, if you're using a script such as an RMD, what's the big deal, right? Like the notebook is going to run from top to tail anyway. What's the matter? And again, hidden state leads to misleading results. In Fusion, it's an RMD or a QMD. In NBDev, they run the entire notebook from top to tail again. So like, what's the hidden state that you're not getting? It's all there. It's difficult to refactor into reusable components. Nope. Both of these tools take the code that you prototyped and send each of the components to the right place, whether it's testing, whether it's modules, whether it's examples, plots, all of that. Both of these tools solve that problem. Version control is a mess, especially merge conflicts. It doesn't matter because the code itself is a module in Python or is a package in R. Both of those are plain text. And so the version control problem of notebooks is solved. There's a lack of separation of concerns. I would argue that that's an anti-problem. I think that, especially in data science, the concerns should be coupled because I do want to see my function produce the plot. I don't want the plot and the function to be separate. And I don't want the test to be separate from the thing that tells me that the test succeeded. I want to be able to see all those things in one place. It's difficult to test automatically or integrate into CI pipelines. If we're generating modules, the tests are generated as well by both Fusion and NBDev. And I'm just going to forget about it anyway. This is bad, especially in data science. You should not be forgetting how you came up with the idea to fit a certain model when you present it as a paper or to your manager for your next data science product. You should not be forgetting why that happened. You should not be forgetting your thinking process. This coupling should be the point. So, just to round it out, I'm not trying to be a software architect or like a professional software engineer or like anything like that. My personal title is actually research software engineer. So what I'm trying to do is I'm trying to move science along as quickly as possible without letting it break. And to me, when science breaks is when I can't explain how I did, why I did it, or why it works. And so for me, notebook-driven development enables this fast iteration, this reproducible thinking. But it also gives me access to high-quality software standards. In short, I want to stop punishing scientists for not writing enterprise-grade code. I want to be able to think, code, document, package, without leaving the notebook that enables all of that to happen in one place. I want to embrace a tool that supports thinking, learning, and doing. And to be clear, these tools are not perfect yet. I'm not trying to say that Fusion or NBDev are like the holy grail of something. They can improve, and they should. I think it just requires that we all critically examine them and make sure that we test them out every so often whenever there's a new feature, just like we do with all of our favorite libraries. Whenever there's a new feature, import it in, see if it works, see if it helps. All right, so that's it for me. I'm going to then go into examples, but I just wanted to give a second for anybody to ask any questions if they wanted to get any clarity on some of the slides. Please let me know. I'll give us all 15 seconds to breathe.
Had seen Fusion, I don't know, a long time ago and hadn't really thought about it since I first saw it, but now I'm thinking about it a lot. And it seems like in modern development, where the style that a lot of people are using for development, um, you're developing by chatting anyway. So storing that chat in a notebook kind of makes even more sense, it seems like it really intriguing. I was actually a little surprised poking over at Fusion's package down that even in the dev version, they didn't have any mentions of AI yet. And it seems like a way to like get some attention on it because it seems like something that would work pretty well, probably. It's just
Absolutely.
really, yeah, it's intriguing. Um,
Absolutely. I do, yeah, I do agree that like it's this, perhaps today, now that we have normalized the idea of communicating with an inanimate machine,
Yeah.
there's more reason to think about this as a viable way of actually developing, because you're literally saying to yourself, hey, what does this data frame look like? And then it prints it out for you. Keeping all of that history in the notebook itself is part of the development cycle.
It's definitely intriguing. I will give it that.
All right. So for the rest of the time that we have, I'm just going to show you how easy it is, at least in my opinion, to get this going. So NBDev is very straightforward. I already have it installed here. It took about 3 minutes, but it's just a pip install. And you can go to the docs to see exactly how this works, but all you're going to do is go nbdev new. It'll ask you to give a value for your repo. This is what they're going to automate. A lot of it will be automated for you. So I'm just going to say nbdev example, branch main. And even with just that many steps, what it's already given me is a fully compliant Python package. You'll see here, this NB's folder is where they expect you to put all of your IPyNB notebooks. And you can see that they already give you some of the scaffolding for it. The index is what makes your Quarto landing page, where it already tells you, like, it already gives you the sort of infrastructure that you could fill in with all of this how to use kind of stuff. But from here, it really is straightforward to start developing your package. Instead of my foo being pos, I could do a print hello. And even, again, going back to that video, I don't want to discredit the original person, but even here, I get all of the code completion and all of the stuff that they were worried about in that video. If I save that file, what I have to do to create the package is I just do nbdev export, and that exports everything that was in these notebooks to the package called nbdev example. And now nbdev example has a file called core.py, where this file is compliant with traditional Python software engineering standards. In addition to that, it's also got the project.toml, if you're into that kind of stuff. And it's got the setup.py. I didn't have to create any of this by hand. It's just there for me. And now if I wanted to install it, I would do pip install -e dot. And now I have a package called nbdev example in my Python environment. If you don't believe me, here we go. And I could do import nbdev example. I gotta change the kernel. There we go. And there you go. Now in nbdev example, I have I should have a foo function here. Import. Well, let's not spend too much time figuring that out. But the basic idea is that you write whatever you want to write in here, and then you tag the cells. So this one is an export cell. And this is basically what gets sent to this core.py, whatever. Pretty simple. And then you can iterate as much as you want. In addition to that, if you do nbdev prepare, it goes through the entire process of both testing the notebooks, rendering them to Quarto, and putting them in proc docs, for which you can see whatever. Let me show you the finished version. So this is a package that I worked on. Fortunately, this is not anything proprietary, so I'm comfortable showing you guys. It's a spatial aggregation pipeline, which takes data from what's called the Era 5 spatial data store. It grabs data from Madagascar and does a spatial aggregation of things like heat, things like precipitation, soil moisture, all this kind of stuff. And so you can see that as I was developing this package, I started off with the QMD where I just sort of told it, like, this is what I want to do. I made my cells. I used the hides. I used the exports, et cetera, wrote all of my stuff in that I wanted to do. And then I started talking myself through the process that I was interested in. We'll need to fetch the sundown and sunrise times for the region and use them to compute the diurnal averages. We use the Astro library to get the sunset and sunrise times for specific latitude and longitude, blah, blah, blah. Get an example file. And I was iterating on this with a Python Jupyter kernel here. And so you can see from here, I can just run it. And if I wanted to know what the DT object was here, I can just say DT. Okay, great. That's what it looks like. What is chords? ds.chords. I know exactly what it is. And as I'm developing, I can always inspect everything that's happening in this notebook with immediate feedback as to what I'm making. So that's what it looks like in nbdev. If you're familiar with R, you can do it in R with the Fusion package. Fusion, you would just say create. And agree. And with that, we have what's called the dev folder. And the dev folder creates a bunch of scaffolding that lets you fill things like the R description. If you've ever worked with R packages, you know that like doing stuff like the description is a long and tedious process. But here, Fusion will just let you do it, and there you go. Description's all filled in. You could do a share on GitHub right from the cell. Use Git, vaccinate, blah, 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 use readmd. All of these things are already filled out for you. And then what they do is they give you a notebook where, sorry, let me make this bigger. They give you a notebook where they say, okay, for your function, you first set the header, and then you write down then you import the different code chunks. just like with before in the NBDev context, it was hashtag pipe export. In Fusion, in R, they do development dash function. So that just initiates the Fusion reader to say, okay, everything below this is going to be a function. And so you just do what you're used to. In here, you write a simple function, my median, you annotate it with function, and then you do the Roxygen thing of adding all of your documentation in here. And you do an examples, and these examples are going to be then displayed in your package vignettes, because this thing called flat whatever gets exported to a vignette. You want to see how that, oh, and the other thing is that the tests, if you annotate one of your code chunks with tests, then you can use the test.package to add the specific tests for that function in one go. If you want to see what that looks like in full, here is a package that I've been using to harmonize DHS data for Madagascar. As you can see, the home page is built as you would expect from the R Markdown README, but the vignettes all come from actual functions that I was developing interactively. So this vignette called linking and tracking raw outputs comes directly from this file, linking and tracking outputs, where I was just saying to myself, okay, I need to figure out how to track each of my input and output files. And so I wrote functions where I was communicating to myself and to the audience what this function should do and why. I use the function annotation here. You do your regular Roxygen commands to put in the documentation, and then you write out the function, you put in your example, you put in a test, and you move on. And you can see here that this file called flat linking inputs gets exported to two places. One place is the vignette called linking and tracking raw inputs. And the other place is the R file, where each function gets its own R file. And then once you've done that, you can use package down to build everything that you need. And so now both your own audience and yourself have the full vignette that was used to actually make certain functions, but also includes all of that documentation that was being used while you were coming up with the certain function itself and why it might be useful. So that's it for notebook-driven development from me. The last thing that I want to say, part of my motivation for doing this and for talking about this today is not just that it's a cool tool, right? It's not just that it's like super fun to use and super helpful and all these things. The other thing is that I didn't start in software engineering. I didn't start in software development. I started in psychology. And in one of my first coding courses, I actually did get that interaction of like, do you actually belong here? Are you in the right place? Kind of thing. And I don't want anybody to ever experience that. That's not a good way to learn. There's no reason for software engineering and programming to treat people that way. And I think that notebook-driven development is a huge opportunity for us to continue the ethos in the data science learning community of welcoming and being open and being a vibrant and kind community, because it's a tool that helps people who may not be super familiar or super confident in traditional coding be able to get their feet wet and get started and write as much as they need to for their task without having to deal with all of the scaffolding and all of the huge requirements of traditional software engineering, but still be able to deliver. And I think that's really special. And I look forward to seeing how notebook-driven development tools evolve. So
Awesome.
thank you, John.
Yeah, thank you. It's a very interesting idea. I back at the beginning of our book clubs, the Advanced R Book Club. Nope, it was the R Packages Book Club back in late 2020, I think.
Mm.
I did a video, or I did one of the chapters and kind of refocused it on. I still do this somewhat, but back then I was very big on all the development I did was vignettes and packages. And then when you need a function, you put it in the vignette and then put it into the package. Like
Right.
that was my method of developing. So I was already doing this kind of thing, but it's really neat to see the structure for that, of
Yeah.
taking it an extra step.
Yeah.
Um,
And it's really
yeah,
important because what you were doing is so labor intensive. And when it's labor intensive like that, it leaves room for mistakes, which is where the software
uh,
engineering community
right.
might have some very serious
Uh,
arguments.
I mean, it was just like cut and paste once you're done working it out. So it wasn't that labor
Exactly.
intensive. But yeah, having a structure around that is a really neat idea. So
Mm.
I'm gonna have to take another look. I think like I have my ways of doing things. I don't know how easy it would be to adapt, but I think it's a great way, if you aren't already set in your ways, this would
Yeah.
be a good way to get set in. So
Yeah. And as I mentioned, the tool is not perfect yet. Neither of these tools are perfect yet.
right.
But the paradigm is something
Yeah.
that I really want the community to consider. Because the more eyes we get on it, the more interest and the better the tools get.
Yeah. Well, like I say, a lot of people are doing development by chatting with a robot.
Right.
And if you just log that as an RMD, that seems like a good idea to me.
Yeah, absolutely. And yeah, Jackie, thank you for joining us as well. Yeah, like it's essentially how I wrote my first paper was by writing a notebook first, where it was only the method section and the analysis section, um, and then sending the output of that notebook to the PhD student who was writing the paper, and then they put it into the paper as a Word document. So it's very, very useful.
Been there, done that, yeah.
Great. All right. Well, I need to run. But
Yep.
again, thank you very much. And I will see everyone next month, if not before.
Awesome. Thank you, everybody.
Bye.